All right. Good afternoon. Many of you know me, but I'm the speaker today, and I'm an assistant professor at the LBJ School of Public Affairs and also in mechanical engineering. And I've been organizing the symposium for the last 5 semesters, and many of you in the audience have probably wondered, so what do you do, right? So that's why I took this opportunity and I said, okay, let me share with you guys, with this audience, what we do in my research group and try to have a discussion around that. The first few minutes, what I want to do is talk about something which is not the subject of today, and really I want to do that to provide some context. We use a whole variety of tools in my group to study 3 different areas. First is climate change policy, energy and development, and technological change and energy. So basically questions around how innovation happens in technology, how that diffuses to the marketplace, and what is the role of policy and regulation to make that happen, or to act as barrier for that matter. And I've studied a whole number of energy topics, including carbon capture and storage. The pointer will not work on that screen, but carbon capture and storage, that's on the very top. That's all the projects in the world, and we try to model what the diffusion trajectories could be. What you see in the center is the CO2 savings that can happen if there are certain regulations put in place in India. And those are massive. And then what you see in the bottom is some resource estimations of what resources might be consumed if CCS were to put in place at scale across globe, and what type of CO2 savings might happen. So that's the general scope of work I do. As I said, we use a whole bunch of tools, mostly quantitative. We use a lot of financial modeling, a lot of econometric modeling, and also, as I'll show you, recently we started using agent-based models. But this work, the next 3 slides are some very specific examples of our recent outputs from my group. This is some work that I've been doing with Scott Robinson on behavioral economics of adoption of technologies, and how our choice to adopt technologies or not is influenced by what our neighbors are doing. And turns out it has a huge impact, not only on our choice, but also on how technology aggregates and how clusters form, and that has huge infrastructure implications. We're also doing a lot of work on understanding consumer behavior after adoption of technology. So once certain technologies are adopted, do we not change at all, or our behavior changes in how we interact with the technology and how we change our consumption during different hours of the day, during different seasons, and so on and so forth. And we measure electricity consumption and bills for special customers who might have electric vehicles or solar PV, and then try to compare that with the other folks who don't have those technologies. And that's an area that is very poorly understood, and we are trying to approach that problem from a whole variety of angles. And this is a third perspective, which is actually tries to pull all of that micro behavioral data into almost a simulation model of how things actually happen. And this is GIS coupled, so we use actual land parcels of whole cities. We are studying Austin very closely, but we're also doing work in California to understand how technologies flow. And basically what you do is you try to simulate human behavior and their interaction with the physical environment or the policy environment using minimal number of simple rules. Okay? So individuals go by rules. They can make decisions based on payback periods. They can interact only with their social networks. Their knowledge is limited, and the ways in which they can access further knowledge is also limited. So all those are built in, but there are very few things that are put in, and then you just let the system go. You have thousands, perhaps hundreds of thousands of agents, which can be individuals or contractors. You just let the system go and see how that compares with what actually had happened. And if you are successful in simulating that, then you can use those models for further future projections. Now, it's almost like a full circle for me. This is coming full circle. This is some work I did for my PhD, where I was simulating how molecules interact and react on the surface of nanoparticles. The application was fuel cells for vehicles, and these are, you can see these are the nanoparticles, and there are different voltages, different colors are different species. And it seems like this is just absolutely disconnected. What has agent-based modeling of technology adoption got to do with molecules reacting on the surface of nanoparticles? Actually, from a computational perspective, it's very similar. The molecules have neighbors, and they interact. So the rate at which molecules will react depends on who their neighbors are, right? So from a computational perspective, it's very similar, and that's what really got me interested in agent-based models and so on. So as I said, that's not really what I want to talk to you about. But there are two reasons why I mentioned that. First is obviously to tell you that we do a lot of very cool stuff in my research group. And second, that the tools that you choose really depend also on the problem that you're attacking. You can't use agent-based modeling to try to study something what I'm actually going to talk about, and that's very, very, very important. The past few slides, the previous few slides actually had very clear theoretical focus, had very concise, well-defined methods, and we were able, through good design, collect data that could speak directly to some of those models. That's not always possible. And the problem at our hand, which is international low-carbon technology flows or transfers, is actually one of those complex problems that involves the interaction of different nations across long time horizons. It involves the interaction of firms with regulators. It involves the interaction of customers with firms and their broader environment. And as you will see, really the incentives are very different. And here you're talking about making things flow proactively, which already might be happening, but then there's something else. There's some other force that you want to apply to this whole system. So my point really is that this problem is actually a lot more complex, and direct tools of quantitative modeling or financial modeling or even econometric model do not apply here. And turns out that most of the time the processes that enable and that underlie technology flows are actually a lot more important, and to have very hard-coded, well-defined, robust quantitative methods for that, it's actually very hard. I've not seen that. So before I really get into the content, let me just spend a couple minutes making sure we all understand what we mean by intellectual property. Some very basic stuff. Most of you might already be familiar with it. So intellectual property is basically creation of minds that leads to intellectual assets or information. And the creation could be inventions or music or literary or other works of art. There could be symbols, names, a whole bunch of things. But basically what is really important is they have to have some sort of an economic value, and that the ownership is easily recognizable. Okay, so these are important. And what IP really is, it's a legal right to control the use of the IP. And we can get into more details of what that really means, but I do want to make the point that if you have a patent or if you have certain IP that does not allow you to practice that, it allows you to prevent somebody else from practicing it. It's a very fine point, but it's actually a very fundamental difference. We can get into that. And so there are a bunch of different types of intellectual properties. Typically we think of patents, but then we also have trademarks, we have know-how, trade secrets, and copyrights. And all countries, most countries actually, certainly all the developed countries and most of the developing countries have their own unique legal system. So that's very important. The IP system is actually not uniform, and they have had different time histories, different evolution trajectories in different countries, and that has a huge influence on how actually we think about the problem of technology flow. So let's now get into the content. This Article 4.5 from the UNFCCC, the United Nations Framework Convention on Climate Change, speaks directly about technology transfer, and it says that developed countries recognize the need for technology and will do everything to have that technology and the associated know-how transferred to developing countries. Right? This is in the document, and it's there because it's so fundamentally important. Now, we know climate change is a problem. We call it climate change, global warming. It's there. It's an issue. It's linked to greenhouse gas emissions, and historically, developed countries have been responsible for that. But increasingly in present and looking to the forward, developing countries are going to be more responsible. Countries like China, India, Brazil, and other countries. At the same time, everyone also recognizes that to solve the issue, to reduce our emissions, and to limit the impacts, what is needed is innovation, both in old technologies as well as in new technologies. Right? So there is innovation and R&D money that is needed, but there is also the need to bridge gaps here. And I'll explain what I really mean by bridge gaps, but basically there can be, hypothetically, technology haves and have-nots, and you can imagine where this language is coming from. So basically the assumption is if these are cutting-edge technologies or technologies at the frontier that require innovation, developing countries may not have that. So that's where this whole concept and notion of technology transfer comes from. So that's what is the language. But if you really look at the dialogue, if you really look at the negotiations that happen at the different conventions, it's very, very caustic. It's head-on conflict, and it seems like, that's the rhetoric, that's the language where developing countries say, look, we are very poor, we don't have the technology, don't tell us to do anything unless you give us the technology. Okay, so go away, bring the technology, and let's talk. The developed countries say, wait a minute, we don't own the technology. Technologies are owned by firms like GE and Shell. So yes, we are willing to work, but try to understand that innovation does not happen. Countries don't innovate. It's firms that innovate. It's entrepreneurs that innovate. So we have to respect that system, make sure innovation happens, and then we can start thinking about technology transfer, right? So again, I want to remind you of this, which is it's so fundamental, it's embedded, it's in the core language, and you all know it's important. Yet, if you really look the tone and tenor of the dialogue, it's very head-on. So this is Gary Hamilton. He's a colleague. He's a research fellow at UT. He's a partner at a law firm that he started on intellectual property. And we have been friends for over 2 years now. When he came to my office and said, I do intellectual property, is there anything else? Is there anything you are working on that we can work on together? And so we said, I don't know, but let's go to China, teach a course, and figure out if we can work together. So that's what we did. We went to China to teach a course on low carbon technologies. Right? So that's a hotel with all walls with solar, and this is we hiked the Great Wall, and this is an interesting photo where after spending maybe half an hour looking at the menu and really convinced that I'm going to order eggplants, I was served a large fish. So that's this photo, and this is a formal dinner we were having with the whole class, and this is after we had finished our dinner. And you can see all the veggies, and that was all for me. When I said, look, I don't eat meat, and so they brought like 10 plates of veggies and piled it all over the table. But it was a lot of fun. But really, what we came out with thinking is, this is such an amazing country. There's just so much investment happening, just so much activity. We visited several wind farms, several solar companies. A lot is happening, and we see a lot of foreign workers, a lot of foreign technology here, and something is amiss here, right? I mean, technology is flowing, investment is flowing, and so what is happening at this international dialogue? So that really was our jumping point, and we said, yes, there is something at least to start exploring, right? So the first, we started looking at this from a very basic perspective and said, okay, let's figure out, is this a problem? Let's do some literature survey. Let's talk to some folks. And is this a concern? And certainly the answer is yes, it is a concern. And we were able to find some very high-profile IP cases where companies like GE or Siemens have had issues and with major technologies, right? And these are very high-profile cases. And we also looked at the literature, and the literature said, yes, there are issues, and this hurts innovation, and in the longer term, this is not good. It not only hurts transfer of technology, but it also hurts innovation incentives in developed countries, right, where these technologies are getting developed. So yes, it is definitely a concern. But then beyond that, we really couldn't find much, right? So it's a concern, but still you see a lot of investment, a lot of technology. Why does it happen? Who is doing this? Under what conditions, right? So that's where we started getting convinced that there's a lot of interesting material that is uncovered. The structure of the problem is not well understood. And I want to tie this back again to the methods question, right? This is research. You have to be able to use scientific methods, and those methods can be anything, to answer a question. And so when you're looking at processes, you have to use different types of methods, and some of which you will see soon. And so early on we built this database of partnerships, and I'll talk more about this. But basically what we saw is that over years, these are partnerships in electric vehicle solar gasification between foreign firms and firms in China and India. And you see the 9 here at the lower left corner is all the partnerships before 2009, and you see 2009, 10, it's been almost like doubling every year. So more and more partnerships. So it fuels our suspicion that something more is happening, right? And these are just 3 very focused sectors. If you broaden your net, you will obviously find hundreds, possibly thousands of these partnerships. But we are very narrow in our focus. So basically, what we wanted to do is these are our research questions. To what extent IP is a barrier, and under what conditions? How do you explain and try to understand that, irrespective of how strong those barriers might be? Why is technology flowing? And if it is flowing, there must be certain strategies that companies can use to make flows happen and still make profits, right? They have to go answer to their shareholders, so they can't be doing business in China unless they are able to make profits on a long term. So what are those strategies? How do you basically understand this conflict? And then finally, what are the implications for innovation generally? Innovation in emerging countries, but also the global innovation system. So in terms of methodology, what we decided is we'll focus on 3 technologies: electric vehicles, coal gasification, and solar PV. There are other things that are possible, but we focused on these 3 because they're very important, because they have characteristics that vary along important directions. And in a moment, I'll point out why they are important. Dave?
So is this between Chinese and Indian, or U.S. Chinese?
Very, very good question, Dave. Thank you. So Dave's question is, what are these partnerships between? And these partnerships are between Chinese firms and foreign firms, but mostly U.S. firms, and Indian firms and foreign firms, again, mostly U.S. Okay? And the way we went about building this database, it was a very standardized process. We came up with keywords, keyed them in Google and keyed them in Chinese search engines, and went through all the search results, documented, did additional research through websites and so on. So this was basically the universe of all that we could get using our methodology on these partnerships between foreign firms and Indian and Chinese firms in these 3 technologies. And the second thing we did is, as I said, this is about process. So we wanted to get deeper insights, and that's where the expert interviews become very important. And this is something not what you do in agent-based models or financial models, but for questions like this, it actually becomes very important. And that's where some of the very interesting insights actually come from. And so obviously you have to be very careful. You cannot make deep conclusions just based on 1 or 2 interviews. You have to interview many experts, but also make sure that they have different backgrounds, different incentive structures, so that you have a lot of information coming, but you can make sure that it's scientifically valued. At least you can make that assessment and try to make that. You have to make that assessment as a researcher. Right, so once we had built the database, what did we look at in the database, and how did we go about building the database, but also what did we explore through the interviews. And so this is a schematic of all the different factors that are important and that impact technology transfer. And it may not be readable, but the arrow there, the two boxes, are basically more on the market characteristics and technology characteristics. So basically, how large is the market? How integrated is the technology supply chain? Are there only 2 or 3 firms globally that supply that technology, or are there hundreds of companies that can sell that technology to an interested buyer? So those kinds of things. And then technology characteristics. How cutting edge is the technology? How much know-how and how much process knowledge does the technology involve? Or is it just a piece of hardware? These all are actually very important. I'll point out some how they actually are important. Then, and the arrow here, the arc here, actually, the 4 boxes are more on the country characteristics or demand side characteristics. So how strong is the IP system? How favorable are domestic policies? How favorable are the input factors like manufacturing or capital, labor? That's very important. And then finally, is there absorptive capacity in the interested firms and countries? And absorptive capacity is basically, if you bring some new knowledge to me, do I have the capability to assimilate that and value that and then use that to become more productive, right? It can be applied, the concept of absorptive capacity applies at the individual level, but also at the firm and as well as national level. So we looked at all these factors and try to explore them through the database by doing secondary research online and through other papers and lit review. And then also, these are exactly the dimensions that we explored in each and every of our expert interviews, which each of them lasted a little over an hour. So what did we find? And I'm just going to throw out the answer first and then go a little bit into how we got there, or some additional findings basically. So do IP regimes matter for low carbon technology transfer? And our first finding is, seems like that for most materially important low carbon technologies, it does not matter. Let me explain. So materially important technologies, the way we define it in our paper and our research, are technologies that are mature, are at scale, are reasonable cost. And one way to measure that is to what extent they're deployed in developed countries. Okay? If the answer that they're not deployed at scale and they're expensive also in developed countries, then we don't classify them as materially important technologies. Okay? So what we found is for materially important technologies, which are mature and cheap and so on, available at scale, and there are several firms providing that technology, IP is not a barrier. And those are the technologies actually that are actually very important for reducing emissions in the near to mid-term, right? And there is a next wave of innovation that needs to happen, that is happening, that is expensive, will happen. That's obviously not covered here. And there are factors and drivers that will impact how that moves. But anyway, so that's one of our major findings. We also, though, did find that IP is a barrier under certain conditions. IP is a barrier for cutting-edge technologies. Again, by definition, cutting-edge technologies are probably not at scale, probably more expensive, right? And the firms who are innovating those technologies have not had the chance to appropriate all the benefits of the investment they have made in the R&D to arrive at the cutting-edge technologies. So these are the characteristics that make IP a barrier for cutting-edge technology transfer. For fully embedded or codified technology, so if all the knowledge that is there in the technology can be codified here, it's actually very easy to reverse engineer, right? And so those technologies are actually at risk. And those are the technologies that actually have been at risk, and historically they have had issues. So we find that as a major concern. We found there are several companies that have major technologies, but they're very concerned that if they're not careful in how they actually engage in business partnerships and who they engage with and under what terms, it might be very easy for them to just lose their technology because it's so hard-coded. As against, if you have a technology that involves a lot of know-how, a lot of process. Process is how materials flows, how temperature and pressure and so on impact the performance of devices. Those are more know-how, human capital-based things. And those are much harder, actually. It takes a lot of investment, a lot of operation to actually acquire those skills. So that's an issue. And then, very interestingly, technology transfer is also a problem for small firms. And there's a lot of literature that says just the opposite, that says that small firms are more likely to transfer technology. Can anybody think of why? Why can you make the case that small firms would be more likely to transfer technology? That's what part of the literature says. Umar? Firms want to make money. And maybe part of it is becoming famous. So basically, the argument is that small firms have less to lose, right? They are more risk-taking because if they engage, that is the only way they can test and sell and so on and grow. So if they lose, fine. But that's actually what we find is just the opposite. And I'll explain in a moment why so. But we do find that small firms have a much harder time trying to do these technology deals in foreign countries, emerging economies actually. So going a little bit into what we find in the database and then try to illuminate them further using the interviews. So this here is the motivation of different firms in actually forming the partnerships. And let me take a moment to just go through the axes. So y-axis is the number of partnership. The x-axis are the different categories of motivation. So is the motivation to join the partnerships? Is it related to market access? Is it related to technology access? Is it related to information access and so on, right? The chart on left here is for the foreign companies that are operating in these partnerships. And the chart on the right is for the Indian firms that are part of those joint collaborations or partnerships. The hashed columns are Indian firms or Indian partners, and then the solid is Chinese. And what you really see is and this is consistent with most of the literature, that the major motivation for Indian and Chinese firms to engage in these partnerships is really getting access to technology, right? And that's actually this chart, and getting some experience and some informational access. So the longest bars are actually technology, information, and experience. And that makes sense. That's very consistent to what other folks find too. If you look at on the other side, the highest motivation for foreign firms is actually access to market, and then a small bar on the technology and so on, and capital and manufacturing. That's important. Low-cost capital, low-cost labor, and manufacturing capability, the supply chain, and the ability to manufacture things at a low cost. China does that very, very well. So that's an important motivator. So these are fairly consistent with what other folks have found. So that's good to know that this database is not out of the whack totally. But there's one thing that we found was actually very interesting. Most of the literature says that foreign firms who form these partnerships bring older generation technologies, right? Because if they try to engage in cutting-edge technology transfer, they are more at risk. So by implication, they would bring older generation technologies and reduce their risk. Okay, so that's what most of the literature says. What we found is it's actually a little different, and one really has to understand what is happening in the market, and for certain technologies, what the markets are in some other parts of the world, in developed countries themselves, for example. And two key theoretical underpinnings are important to understand that. First is everybody, Chinese, Indian firms, emerging economy firms, or firms in the developed countries, in this globalized economy, they have to stay at the technological frontier to be competitive. You either have to be extremely low cost, or you have to have really good technology that has a lot of demand. However you measure that, you really have to be extremely good at something, right? That is how you create demand for your products. So you have to be at the technological frontier. The second thing is that to be able to innovate, it's very important to actually do that, right? Creating ideas is one thing, but creating products requires a lot of learning by doing, a lot of building things, and then incorporating those knowledge that knowledge moving forward. So, there is a lot of economic literature around these things. Now, it turns out that there are technologies that the only way you can build those technologies are actually by operating in emerging economies. Can somebody think of any of those technologies? What is a important low carbon technology for which we don't have a market in the US? Quiz. Nuclear power is a great example, actually. It's a very good example. We are not building anything here, and China is building a lot. Middle East is building. Abu Dhabi, we heard from Dale Klein last semester. Great example. Anything else? Cheap light bulbs. CFL, I think we certainly have a large market here, but
I know like India has a thing where they're buying a ridiculous number of them.
Right, that's true. So that's true. So they can have specialized programs. Now, what are we not building here in the US? So we are not building nuclear. What else are we not building? We have heard it over and over again here. Sorry? Refineries, and maybe we'll start building them more as we get more gas. PV? So obvious, come on. That's it. Shama has it, right? We are not building any coal here, right? And what is an important low carbon coal technology? CCS, carbon capture and storage. We have had some talks, several speakers talk to us on CCS. So, my postdoc advisor, David Victor, and I wrote a Newsweek international piece in 2009 where we argued that dirty coal is winning. And that was the title of the piece. We didn't choose the title. The editor chose. We had something else. But the basic message was that because of the financial downturn, the economic crisis, we will never have clean coal in the US. Why? Because to have clean coal, you have to build clean coal. You have to learn what the issues are and then scale it up and build more of it. And what we are arguing is there is no money. Wall Street is hemorrhaging. They don't have the risk appetite to fund coal plants, and because of also a whole bunch of other regulatory issues. So anyway, about 3 years on, it looks like we have moved on from the economic crisis, but what we said holds true for a little bit different reason. And the reason it is true is because of natural gas, and we have heard that again and again and again here. So this picture, this chart really is from National Energy Technology Lab. It shows the operational and under construction and planned coal capacity in the US and in China. US is red and yellow, right? So the red bars are actually how much capacity came each year in the US, and yellow is how much of it is under construction. And there is, as you can see, there is nothing here, which means nothing is planned in the US beyond 2012. We don't have anything on the cards starting next year on coal. So nothing that is happening. Look at China, right? Every year have 75, 80 coal plants. Maybe if they're smaller coal plants, there are actually more number of coal plants. But also look moving forward. If that is the case, and if you are GE or if you're Shell, if you're Siemens, if you have an interest in staying competitive in clean coal technology and developing clean coal technology, no matter how much you fear other things, the only way you can do business and stay at the frontier and build the technology actually is by being in China, right? So I think that's one of the key findings that we found was completely new and at odds with what was mostly said in the literature, which is because you have to understand the market conditions and how the technology, what the spaces are for the technology globally to operate. And it turns out that maybe the only places where these technologies can deploy and have learning by doing and reduce costs and innovate are by operating in emerging countries. And the conclusion there is, it's not only the older technologies that get transferred. And several of the experts in the interviews from these firms actually said that they are deploying absolute cutting-edge technologies in China because that's the only way they get experience, right? So moving on, the next piece is, I really need to hurry up actually. So this is about firm size and firm combination, and really the message here is, the numbers will be confusing, but just look at the text here. What we find is that in the Chinese firms, we find a lot more large Chinese firms, and the way we define large is if those companies have greater than 10,000 employees. So we find a lot of large Chinese firms in those partnerships, and we find smaller firms on the Indian side. And that's kind of interesting as to why is this difference. Both are emerging economies, both are rapidly growing, China more than India, and then both seem like very interested in low carbon technologies. So why, and both of them have weak IP systems. So why do you have this difference in, why do you have the size bias? And maybe there's something interesting there. And it turns out there is actually something very interesting there. First of all, IP concern. Systems are weak in both the countries, but the concern is a lot more in China than in India. Okay, it's because China is more capable than India when it comes to technological innovation and technological and manufacturing in advanced technologies. Okay, so to take something we discussed already, absorptive capacity language. China has more absorptive capacity and more innovative capability than India, and so by definition then firms will be more averse to bringing technology to China, or they have to be more careful. Okay, so that's what really matters. They have to be more careful, and one way in which you can be careful is by partnering with large Chinese firms. Why? To understand that, one has to understand the logic of the operation of the IP system, the legal system. So what we found is that obviously there is the formal legal system, institutions and IP laws and courts and so on and so forth. But it's also actually very important to know that there is a parallel system in the sense that institutional connections, political connections, and knowing important folks, having a reputation of a large state-owned firm, all of this matters in how firms are actually able to implement or protect their IP. Okay, so because of these considerations, because you have a parallel system where you can enforce IP in parallel and without even going to the legal system very formally, there are ways in which IP may be protected, and that's why you see a lot of foreign firms trying to partner with large Chinese firms, because with large Chinese firms comes their reputation. So the chance, because they're not just large Chinese firms, they also have large international operations. So the likelihood that they'll run away with the technology has huge reputational impacts on those firms. So they're less likely to run away with the technology. Second is they have all these informal ties and connections which are extremely important, equal if not more important than the formal IP laws. And then third, these partnerships, most of these partnerships are actually joint ventures, and a joint venture is a domestic company. So the inherent bias against a foreign company, which is true anywhere. There are instances here in the U.S. There is some literature that says there is some bias where domestic companies are favored anywhere in the world, basically. So even that bias goes away if a foreign firm partners with a Chinese firm and forms a joint venture. And so recently we have seen movement away from licensing and towards joint venture, and there's some very interesting reasons why that may be happening. We can get into that during the Q&A. And so let me see where we are. Okay, so few other things to mention. We have talked about the fully codified and process-oriented technologies, but one thing that is happening is the foreign firms that are forming these partnerships are trying to have more process innovation because it's easier to protect those technologies. So they're moving away from codified technologies. And second, they're also investing heavily in IT to actually manage that IP. And so there is a lot of very sophisticated information technology that surrounds how IP gets shared and how you can control and monitor sharing of your IP layer by layer. And it turns out that firms typically are happy now in these JVs to share 80% of the technology, but still try to maintain some very, very control over some very critical parts of the IP, just to create some interdependency. And then second, they're also moving to fragment supply chain. So if all your supply chain is in one factory or at one location, again, it's very easy to lose that technology. And so what firms are trying to do is take away their parts of their supply chain and then put them in different parts of China or even put them in some other countries so that they hedge some of the risk of the technology just going away very easily. Okay, let's move to the last part. I'll spend maybe 5 minutes here, which is the question of the level of innovation. What is the innovative content of these partnerships? So far we have talked about the motivation in these partnerships, the firm size and how that is relevant for production of IP, and then the third piece is there any innovation content in any of these partnerships? And the answer here again is yes, and a lot more for China than in India. And it goes back to my prior point that China has a lot more absorptive capability. And what it does is it gives China a higher leverage. But what is also important is China does it very strategically. They're able to see something, try to value it, and if their decision is yes, it's an important field, it's an important area, and we want to be players, they just try to align several pieces to make it happen. And that has a huge impact. Several of in our expert interviews, what we found is a key difficulty these companies are having in deploying technologies even in developed markets, and US is a good example, is because of lack of policy coordination. Whereas if you're in China, these firms really like that business and policy environment. Once China has made a call that we want to do this, all the uncertainties or most of the uncertainties around commercial issues and associated legal barriers or policy issues evaporate, because China gets its cards very aligned. And that's actually very, very important for any business, but certainly very important for innovative technologies. Right, so let's take the example of solar PV. So China used to produce only 2 or 3% of PV cells 7 years ago, and now it produces 60%. And that's just almost mind-boggling. And how did it do that is actually very interesting. So solar PV is, this is what you see, but basically there is a lot that goes on behind. It starts with the silicon, you purify it, make it into ingots, those are the cylinders, then slice them into wafers using some very sophisticated technologies, then make the panels, put them into arrays and so on, and you get your panels, and then you have to put a whole bunch of other electronics to actually produce power from it, right? And so the point really is that each of this is actually a different part of the supply chain. And there are different technology suppliers. There are different ways and different players and actors in different parts of the supply chain. The upstream, right, the silicon part and the wafer part is actually very concentrated, meaning there are very few players internationally that have that technology to actually produce the wafers and or produce silicon ingots. And this was more true 5 years ago when actually China was starting. As against for cells and modules, the concentration, industry concentration is very low, meaning it's very competitive. You can buy the technology from 100 different players. Okay, and that has huge implication. At the same time, if you look at the profits are much higher on the upstream. So where the technology is technology supply is very concentrated, that's also where you have the high profit. It makes sense, right? And so these numbers, what they say is there was only one firm, this was probably 2007 or 8, that was willing to provide a turnkey ingot and ingot manufacturing facility. Only one firm globally. There were only 9 that were willing to provide a turnkey project for wafer manufacturing, but a lot more on the module side, right? Now, that's very interesting. Now, if a country like China wants to start producing PV, what do you do? So they start strategically, and they start with the downstream, where there's a lot of competition. And that's exactly what China did, is they started becoming very active in the upstream. They developed capabilities, so several domestic Chinese firms were actually able, within just a few years, to incorporate foreign technology and provide turnkey solutions themselves domestically. So they became independent technology suppliers, and that was much harder to do on the upstream because the technology is concentrated. You're not able to break into the technology supply chain. So what do you do? If that is the kind of deadlock, and that is where all the profits are concentrated, so either you produce it or you pay somebody else high money to get the basic inputs to the process, what do you do?
Well, if you're China, you try to buy a company like A123.
You could buy a company, but let's say these are large companies and you can't buy them. Sorry? You could employ them to do what? So knowledge. So basically you could try to innovate, right? And that's exactly what China did. So if you look at this, these are patents that China filed or were filed in China by Chinese firms along different pieces of the value chain. And you see the most patents were filed upstream, meaning innovation money and innovation direction was actually strategically directed to a piece of the value chain that was much harder to actually get from international markets. So that's what I mean when I say China has a very coordinated view of things. And that turns out, that becomes very important. Why? Because now if you are a foreign firm, you're seeing domestic innovation is happening, and in a few years, your business will be attacked, right? Because once there is this view that it's important, there's just a lot of pieces that come together, so it almost becomes inevitable. And there is some hand twisting that goes around here, but also some basic R&D and a lot of money and coordination that plays in. And what it ends up being is actually increases domestic leverage, and the implication for foreign firms is that they have to act today to strategically engage in that market. Otherwise, they may not even be in the market 10 years from now. Absolutely. Because the domestic firms are coming, basically. Okay? And that's something, the firms that operate in China, many of the experts said that folks who don't know the Chinese market, have not operated in the Chinese market, do not understand this. How active, how vibrant the domestic innovation scenario is. And I'm not suggesting that it's high cutting edge innovation and it's at par with the US. Far from that, right? But still, because of the scale of production, because of extreme learning by doing and process knowledge, there is a lot happening, so the absorptive capacity is actually increasing exponentially. And it has huge strategic implications. So as a foreign firm, you have this on top of the other motivations, you have now this innovation threat or market threat motivation to actually engage in China. What I'll do is just stop here and see if we have any questions and engage in some discussion. And Eric will go around passing around the mic.
Let's see, this is...
Go ahead, it will not echo here.
This is really interesting research, Varun, and I had a stint in this area in a kind of historical context, looking at Indian textile technology development and going right from cotton to synthetic, and found somewhat similar findings comparing China and India, particularly in the synthetic and petrochemical, synthetic fiber industry, I think related to petrochemical. And the explanation that I recall, and this was a while ago, about maybe 15 years ago when I was getting started in India in research, that India at that time, of course, and this was prior to the liberalization, had a very strong licensing regime which was targeted at reducing concentration of economic power, basically building smaller plants to distribute the capacity of production across many players rather than having it in one hand. And they systematically set up very small synthetic fiber plants. It worked okay in the cotton textile, but it was a big disadvantage in the synthetic fiber. China, on the other hand, went for the state-of-the-art scale in that area. And I'm sort of seeing a similar thing here. So I was just sort of thinking that China's it's not only the large firms who are probably seeking out large Chinese players, but Chinese authorities, so to say, really benefiting from large plants,
No,
large scale.
absolutely. I think
Because learning by doing, in fact, is a lot easier when you have a large scale plant. Technology has a lot of fixed costs, technology development has a lot of fixed costs, and those become lower. So it could be, both ways beneficial.
no, certainly there are technology acquisition benefits, but there are also branding benefits. Chinese firms certainly benefit by engaging with large multinational firms. One thing I did not mention is many of these Chinese firms also have aspirations to go international and actually do international business, and they're interested in the management experience, not just the technology experience, but certainly the association benefits that comes with working with a big brand.
I would be interested to see what happened on India's side with the patents and other information that you've developed in China.
We haven't looked at the Indian patents, but what the aggregate picture that is coming is the innovation system broadly, but certainly also on the solar side in India is absolutely fragmented. It's an absolute failure. Yes, sir.
Oh, thanks. This is really interesting. My question is just in that last line you've got. You say that China's closer to catching up because they have a coordinated long-term effort to rebuild its national innovation system, which suggests that there was a national innovation system until some event, and that it now needs to be remade. When was China economically very innovative, and what's going to be different now?
Right. That's a very good question, and I think when you talk about the Chinese national innovation system, in the modern economic sense, you can trace it back only 30, 40 years. When the major transitions happened in the Chinese economy in the 70s, right? But the shifts, so they did things in the 80s. They had regulation and deregulation in certain parts of the economy and different parts of the economy, electricity, coal, and so on. Very varying standards and varying policies, which actually were being evolved and changed. At the same time, there were strategic R&D investments being made, universities being created. But more recently, just the last 5 years, in the last 5-year plan of China, one of the key tenets is science and technology-based knowledge. And one has to keep in mind how the Chinese operate. They have a plan, and they have a plan because they are serious about it. And when you put science and technology in the plan, that is what rebuilding is. When you do that, when the Chinese do that, they just rethink the whole thing and rebuild it. And some examples of that is creating hundreds of clusters of different types of technologies. And there's a lot of new economic research around clusters and benefits of clusters, and how if you have a whole bunch of firms in a cluster, which is an ecosystem, then is it more economically productive? Seems like there's empirical evidence that suggests that. So China is using those new ideas to rebuild. That's what we mean by rebuilding its national innovation system. Dave.
Thank you, Professor, for your fine presentation. Good to see you again. A little bit in the news lately about industrial espionage. Any kind of contribution factor you can put in there in terms of, are the Chinese better at that? You look at Building 61, 398, supposedly, and I know it's a sensitive topic, but it has to be part of this equation in some way. Mm-hmm. So how much of that is helping to boost this lead that China has over India, and how sustainable is that over the long term for all parties?
Right. That was, so I'll detach my comments from the research we did, because we did not look at corporate espionage or IP stealing or things like that in our research. We got to some of those issues. We tried to focus more on the partnerships and market characteristics and so on. But I can tell you from what I have read in some interesting, well-researched articles or pieces, it is an issue, right? And it's certainly. There are well-documented cases, and actually publicly available cases, where you see that those concerns have actually materialized, and certainly have given China an advantage in certain cases. For India's perspective, again, for me, what it boils down to is what was the innovative capability first of all. Even for example, even if India were to do industrial espionage, it would really not matter. In the sense, they just don't have those capabilities to build coal gasification plants or turbines or electric vehicles. Although electric vehicles may not be a good example for India because they are doing something there. So very quickly, I'll just say it is an issue. It has certainly given China an edge. It's a very complex, controversial issue which we did not get directly into through our research.
Hi, Professor Rai. Thank you for your presentation. And I have a question about the size of the companies. And you said that a lot of JV in China are big companies compared with the Indian small companies. And in my impression is that the big companies in China, they are big scale because they are state-owned firms, and they naturally occupies a lot of natural resources in China and also social resources in China. So they could have the favorable policies from the government, and they could use the policies to boost their innovations in China. But actually, I think this is an advantage, but also a disadvantage, because in China, I think there is a problem that there lack of very active private economy, especially for the small size and middle-sized companies. Do you think that it will be a problem in the future to be a barrier for future to rebuild the innovation system?
No, I think that's an extremely important point, and I'll just go back to, try to put yourself in the shoes of the foreign firm, right? And given that there are possibilities of, there are IP concerns, and given that the system is still evolving and not well settled, how, as a foreign firm, would you engage? Would you rather engage with small and medium firms, or would you rather engage with large firms? And that's what we find is, at current, wherever the stage of the IP system is, wherever the large markets are, it turns out that only by engaging with these large firms can there be more guarantee, higher probability that you'll be able to protect your IP better. What we also say in the paper, something we did not discuss today, is in the longer run, I think we might actually have, this last bullet here, which is in the long run, strong IP is preferred by everybody, right? In the long run, and the long run is a very nebulous phrase here, but certainly foreign firms like that today, but increasingly, just for the reasons you mentioned, if small firms are more innovative, a lot of economic literature suggests that's where most of the entrepreneurs are, a lot of innovation happens that. And if China is really serious about becoming a science and technology leader, they have to move towards that system. And if that happens, they will have a lot more pressure from within, bottom up, to reform their system and have a stronger IP system. So yes, that dynamic is actually playing out as we speak. And we make that point in the paper.
Yeah, so your graph for the coal plants which are planned for China, these are just coal plants, or are these clean coal plants?
These are just coal plants, or
are they clean coal?
Oh, these are just coal plants.
These are just coal?
Just coal plants, yes. And some of them are going to be clean coal plants.
Oh, okay.
Right.
So
These
probably a very small percentage, maybe.
Yeah, very small percentage. But what one has to keep in mind that China is now building, all of what China is building is super critical, and increasingly it's
I was just wondering with respect to transfer of technologies, by the big companies. So if India or China were going into clean coal, so how much of that part is critical?
It's very low, but that's all there is globally. Okay, so even if it is very low compared to what is happening in those countries, it's basically
it's still very big.
Or the whole portion of the world. Okay.
Okay. Thank you.
If there are no more questions, well, thank you.